Hello everyone, February 19th. Alright, it's a late night. Let's just get this done as fast as we can and then call it a day. Binary tree, zigzag, level, order. Okay, so we return this. We need to do 3, 29, 15, 7. So we return a zigzag level order traversal from left to right and then right to left. Oh, wow, that's not too hard. I think this one is just, we'll do BFS and that's it. All right, how do we do? We have Q equals root. Res is this. Res have to do root, right? So we have to say if not root, return this. Otherwise, this will be root.val. Actually no. We're gonna say for a while Q, right? While Q temp for node in Q, right? If here res.append for node in Q res -1.append or if node, right? I don't have to do if node because I check it here, so I don't have to do. I just do append node.val, and then I just need to record if it's left or right, right? How do we do it easier? We can say left to right. Okay, that's true. And then temp.append .left. Oh, it's better. We just say if node. But if we say if node, we can. Yeah, it's actually easier to do this. We just put a node.left, node.right. And then we'll have to put, you know what? I don't like it. It's not my style. I'll say if node.left. Okay. And then if node.right, we put node.right. And then Q equals temp. And we say if not left to right, res -1 equals res -1. We just reverse it. And left to right, exclusive OR, right? And now we return res at the end. All right, let's give this a shot. Something's not right. Oh, is exclusive OR not right? True and exclusive OR shall be false. That's why I did 29. And then the next level, I did, that one is false and false. Oh, false and false. So that should be, it's not exclusive OR. It should be 1. So I should say if this is smaller than 0, multiply. That'll be easier. It is toggle. If it's true, it becomes false. If it's false, it becomes true. And this one will be easier to deal with. Yep. All right, well, call it a day. Or do you want to? Yeah, I think I want to take a look at the difficult question. I want to know. BFS. I just take a look. Check if point is reachable. There exists an infinitely large grid. You're currently at point 1, and you need to reach the point target using a finite number of steps. One step you can move from point X to any of the following points. Ooh, y minus X. X minus y, 2 times X, 2 times y. Given two integers, this, representing the xy coordinate, is then true if you can reach the point using some number of steps, and false otherwise. Holy crap. So we start from a 1, 1, and we say 6, 9. 6, 9. You either go, so if I have 1, 1, then I know the next step is either 1, 0, 0, 1, 2, 1, or 1, 2. Oh, and then what? One, 0, we can do x doesn't change. So we have 2 is x doesn't change, and 2 is y doesn't change, okay? So 2x doesn't change. So 1, 0, 1, 0, 1, 0, y just minus x. Right, 1, 0. Or 2 times. So 1, 2. Alright, next one for them, if x doesn't change, and then if it's 1, 0, x doesn't change, that'll be y minus x. So it'll be minus 1. Right? 1 minus 1 doesn't change. So 1 minus 2. So one possibility is keep going down, right? If x doesn't change. If the other side multiply by 2, well, 1, 0 multiplied by 2 is still 1, 0. So that's it. Doesn't grow up. It just stay here. Okay, how about this one? This is 1 minus 1. 1 minus 1 multiplied by 2. That's 1 minus 2. Right? 1 minus 2. And then 1 minus 4. Right? And then you can also do minus 2 minus 1. So hold on. Because you can do, just from the perspective of 1, 0. Right? You're going to minus x. So you can hit every single spot down. Every single spot from 1 m, where m is smaller or equal to 0. Every single spot can be hit. So that's okay. How about going up? Well, going up, we can have 1, 2, right? And then 1, 2, we can go down 1, right? Or 1, 4, go down 1. 1, 6. So x, if target x is equal to 1, it's a good. Okay? Target x equal to 1 is good. And that also means, that does not also mean that. So target x equals 1 is good. Just take the full thing. Okay, so that we analyzed at the start what's going to happen for x equal to 1. Now, how about from the start we analyze y doesn't change? So y is 1, right? Y is 1. Y doesn't change. So x minus 1, right? So we extend to the left. Or, why don't I say 2 times x? So that will be 2, 1, right? 2, 1. And 2, 1, we can get 4, 1, 8, 1, and then we can also get, why doesn't change? X minus 1, x minus 1. So, for x equals 1, everything is good. For y equals 1, everything is good. Because we just hit the entire thing. Alright? So now we need to figure out, so we have found that at a 1, 1 position, the entire 1, 1 is all good. So now what we need to do is we go right. Right? How do we move right? So from 1, 1, right, we can go right, which is 2, 1. Okay, 2, 1, because we say 2 times x, right? 2, 1. So from 2, 1, this is 2, 1. We need to do x-axis. Again, the same. So at every single point, we can do this. And of course, if we go up, and we can hit every single point. So we can get to 1, 2, right? And 2, 1, because y is 1, we can hit every single spot as well, vertically, because it's 2, 1, and I don't need to change 2, so just minus y is 1, so minus 1, minus 1, blah, 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 blah. We just keep minus 1, so everything down, and then we can multiply by 2 and everything down, so we can hit every single one. But they say 6, 9 cannot be hit. Why is that? Why is 6, 9 not able to hit? Now what we see is every point can be hit. It's not everything can be hit. Because we're at 2, 1. If next time we move x to the right, can only be 4. Right? We can only be 4. It can be 4, 1. That's why 4, 7 can be hit. Because x equals 4, I can hit the entire vertical. And we can do 8. 8, 1. But when we do 8, 1, can we move left? If we are 8, 1, if I don't change y and x minus 1, so I can move to 7, 1, right? If I go to 8, 1, which is just times 2, right? And then I move to 7, 1. I want to move to 7, 1. I can move to 6, 1, right? I can move to 6, 1. And when I move to 6, 1, can I go up? I'm at 6, 1. Right? Can I go up? More 6, 1. Oh, then go up and down is not minus 1. Pay attention. You need to pay attention. It's not minus 1. Because x has changed. Right? X has changed. Yeah, so what you need to know is if you want to hit the target, you have to first reach x or y. You have to reach them first, right? And once you reach the x or y, like I reach 6, 1, right? X is 6. 6, 1. So for 6, 1, I can go up and down. I can go down because y, no, you cannot. 6, 1, because x, y, you can minus y. So you can move left. You can move left or right because y is 1, right? So you can move left and right every single point. But if you want to go up and down, like you want to say, I want to go to 9, but now y is 1. If you want to go up, you need to, the only way is to multiply, right? So you multiply by 2. So it's 6, 2, right? It's not enough. So you need to keep multiply by 2. So 6, 4, 6, 8, right? You keep going up. And then what you want to find is if there exists, keep multiply by 2. So 2, in this case, whatever start, right? Start times 2 to the, I don't know, k power, right? And then when we would reach there, then we can go down minus your x times whatever will equal to your target y, right? Will equal to your target y, which means y times 2 to the k minus target y mod x to equal to 0. Right? That means target y need to mod x equal to 0. And y times 2 to the k mod x need to equal to 0. And in our case, we start with x is 6, right? And then y is 1. So now we're talking about 2 to the k need to mod 6 equal to 0. That's not possible, right? That's not possible. And of course, target y 9 mod x6 is not possible. So that's not possible. So how about 4, 7? Well, we say 4, 7. So we can reach target to 4. We can see if I reach target 4, can I get to 7? So how do I reach target 4? So we start from 1 and 1, right? We start from 1 and 1. And then when I want to reach target 4, and I can, because I can just go to the right. All right, go to the right is to multiply 2. So I can go to 4, 1, right? So I can. So now the question is 1 times 2 to the k mod 4, because target is 4. Yes, this can be done. And y is 7. 7 need to mod x. Why mod x? Shouldn't be minus, y minus x. Yeah. So I can get to 4, 1. If I can get 4, 1, if I want to go up, as multiply by 2, okay? And then I need to go down. That's not how. We need to go to 7 first. We need to go 7. So go to 4 first is actually not going to work. If we go to 7 first, well, anyway, we can go to 7. So now at a 1, 7, right? So at a 1, 7, we need to reach 4, 7. Oh, that we can do. Right? That we can do. But that's the easy case. Because I'm pretty sure there are things you need to go, you can't just initially go to it and then we know initially we can go to any position, right? We can go to any position where the 1 is a 1. Like if I want to go to target 6, x is 6, we can go to 6. X is 6 will be 6, 1. And from 6, 1, we need to go to 9. That is not possible. Or we can go to 1, 9. Right? We go to 1, 9, now we're going to go to 6. That is not possible. But that's only one possibility. I think there will be cases where you just move someplace and from that place you start going. Right? You move to some place and from that place, any place, X and Y. But you have to reach X or you have to reach Y. But from where do you reach X? And the target and Y are all in the first quadrant, right? So everything is positive. Therefore, the only way to move right or the only way to move up is by multiplying. By multiplying, right? By multiplying. If you multiply, right, you'd say like times 2 times X and we can minus. So let's say I multiply and I go up. Go up is also multiply, right? Which means if you go right, and you go up directly, you end up with even number, all right? If you go right, then you go left, then you end up with an odd number, but then you go up, that becomes an even number again. And if you want to go down, because you already go right, oh yeah, that you go right, that's an even number, then you go left, your X is odd, then you go up, your Y is even, then you can go down, it becomes odd again. So yeah, it can be odd. It can be odd. But at the end of the day, what we're saying is you have to do some steps, right? Trying to reach, like you have to go right certain amount of times, and then you go up certain amount of times, and then you go left certain amount of times, and you go down certain amount of times. You always have to do this type of thing, right? And it's at most, because you want to reach there, if I go right, then I go up, then I go left, and as I reach the target. So when you go right, you just keep multiplying. You go up, keep multiplying, and you go left, you start a minus. So my question is it possible that you do left and right, do 2 times? So left, then you go up, then you go left again. Is that possible? You go left, you go right. So multiply. You go up, you multiply. Then you go right again. Then you multiply. So that's the same, right? So you go right, up, right. It's the same as go right. Keep going right and then go up. Because if you don't go down, you don't go left, the only thing you do is multiply, right? The only thing you do is multiply. It's only if you go up and you go left, right? You go left, then you start minus, then you go right. That's when you change. You change the base. change the base. What are we looking at? All right, what are we looking at? So what we're looking at is we start as 1, 1. You move some, you minus some, that become an even number, or even an odd number, right? And then if you keep going, you have different, and then you minus that, all become even number. No idea at the moment. Go up, have to multiply. So we have 2, 1, 2, 2, 2, 4, right? And when I go down, so at this point, it's all gonna be even number. I don't go right. Go right is multiply. Right? Go right is multiply. So we can have 1, 1, 2, 1, 4, 1, A 1. Right? And then once I this, so I go left is minus. So I can have 3, 1. I can have 5, 1. 6, 1, and 7, 1. We can have all of these because I just go there and then minus 1 coming back because I can do x minus y. So I can hit everything on this, right? I can hit everything on this. We already established that. Then the question is, starting from these positions, what can we get? If I start from 2, 1, I want to go up. Then that's like if we have 2, 1, then go up will be 2, 2, because we multiply 2, and then 2, 4, and then 2, 8. Then we want to coming back down, because I can only minus x, so that will be 2, 6. Right? That will be 2, 2. So it will be 2, 4, 6, 8. Then we can hit all the even number here. Right? We can hit all the even number going up. Okay, so, but we can also hit 1, 2. We can hit 1, 3. Right? We can hit 1, 4. We can hit 1, 5. Because we go up on y from 1, 1, and then we minus 1 coming down. So we can hit everything. So what will happen if we start from 1, 3, and then we're going right? If we start from 1, 3 going right, we multiplied on 1, so we get 2, 3. So 2, 3 can be hit. The next one's 4, 3. Next one's 8, 3. Right? 16, 3. And then we want to go left. That's minus 3. Right? That's minus 3. Which means on 4, 3, minus 3 we go to 1, 3. Right? On 8, 3, we go to 5 3s. Right? We go to 5, 3. And then on 16, we go to 13, 3, 10, 3, and 7, 3, and 4, 3. That's very interesting. What we get is 1, 2, 4, 5, 7, 8, 10, 13, and 16. What are we missing? So 1, 2, 4, 1, 2, 4, 5, 7, 8, but 10, 13. Doesn't make any sense, huh? It does not make sense. No, that makes sense. Yeah, 2 to the 3 minus 3 equals 5. How'd you do that? Well, if you want to hit the target, the last step, think about the last step. Okay, so if I want to go to, 4, 7, okay, the last step to go to 4, 7, I either, come in left, which means if I come left, it's going to be x minus y. So I need to do x plus y. So I have to go from 11, 7, right? So I can go 11, 7 to 4, 7. So 11 minus 7. Or I can go up. Well, I cannot go up because go up need to be multiplied. The 7 is odd number, so cannot go up. Or I can go down. If I go down, then shall be 4, 11, right? Because y minus x. So to get to 4, 7, or I can go from left, because go left to right is multiplied by 2, so I can go from 2, 7 to 4, 7, right? So to reach 4, 7, I have 3 options, and then we check those 3 options. I'm at 11, 7. Okay, I'm at 11, 7. How do we get to 11, 7? Well, to get to 11, 7, I can go from right to left. So we keep going. So we keep adding 7 because we go left to the minus. So that will be 18, 7. Right? To get to 11, 7, I need to go from top down. And it's not possible to go from left to right because both are odd numbers. So from top down, it's just gonna be I need to go from 11, 18. Right, from 11, 18, I can minus 11 to go to here. So bottom up is not possible. So for here we have 2 options. So from these 2 options, that I just keep going one direction. That's just infinite, right? That's infinite. And then from here, I have 18. Then I can say I can go from 9. Yeah, that's just no. There's way too many possibilities. Doesn't feel right. Interesting. I need to think about this. All right, it's late. I'll do this tomorrow, or maybe not. I need to think about this. This is different. The thing is, I think it's like math, but I feel like there gotta be a non-math solution for this, right? All right, I'll see you guys tomorrow. Oh, well, actually later today. Adios.